Now I'm going to look at some more of these literal equations. How about we look at this one? How about A equals 1/2 BH. And let's go ahead and solve that for H. Okay, solve for H here. So what do we need to do? Well, we need to eventually solve for that H, which is here. And we've got a fraction, so let's get rid of the fraction. So we're going to multiply both sides by 2. That'll clear out that fraction. So we'll do that first. And we'll distribute that 2 through both sides. So that's going to now be 2a equals that 2 times the half, that's going to cancel. And that's going to give you bh. Again, what variable do we want? We want the h, which is right here. So we need to get the h by itself. And what's our procedure for doing that? Well, how does that b relate to the h? It relates to it by multiplication. And what's going to undo that multiplication? Division. So we'll divide both sides by that b. And that gives me then 2a over b equals h. We always like to switch it around so your variable that you want is on the left. So that gives you h equals now 2a over b. Yeah, okay. Now, why did I use a 2? Let's go back and look at this. Okay, I need to get rid of the half here. So this is all one piece here with multiplication. And so I multiplied both sides by 2, because that 2 and that half, they're going to cancel. So when I do that, it has to go through each side. So then the left-hand side becomes then your 2a. And then 2 times the half here, well, 2 times that 1/2, they cancel. So then that goes away, and that leaves you with the BH there. Does that make sense? So multiplied by 2. If that would have been, let's say, a 1/4, you'd multiply it all by 4. If it was a 1/8, you'd multiply it by an 8. Okay? Let's do another one here. And I'll just do the formula for temperatures. Let's say I gave you this. And let's go ahead and solve this for C. So we want to solve this for C. What we're going to do first is we're going to try to get rid of our fractions. So I'm going to multiply everything by a 5. And we'll distribute through. So multiplying everything by 5 to clear out that fraction. When we multiply through, we get 5f equals, okay, the 5s, they do what? They cancel out, so it gives you 1 times 9, that makes it now the 9c. And then we have 32 times that 5, and that's 160. Is everyone okay with that so far? Now this one has several steps in it. So we cleared our fractions. We multiplied everything by 5 to do away with those. And then we want that c by itself. So this one's actually going to have a little bit more. It's going to have an extra step. So we're going to move that 160 over. Now we've got 5f minus 160 equals that 9c. Okay, and we want to still solve for that c. So we want to get that c now by itself, which is here. So how do we get that c by itself? It's got a 9 in front of it. 9's related to the c by multiplication. divide both sides by 9. And it's going to go over all of it. You don't have to break it down or split it up anymore. So the 9's cancel. And then that leaves you with 5f minus 160 over 9, and that equals c. You don't need to break this down. You can split it up into separate fractions, and you can reduce them down. I would just leave it the way it is, though. Okay, so just leave it the way it is. We'll put that c on the left, so c equals now 5f minus 160 over 9. And you can split it up into individual fractions, or you can just leave it the way it is. I would just say leave it the way it is. So we cleared our fractions. We then saw we needed to solve for c, so we got that 9c by itself. We divided by 9, and don't try to reduce down that 169. Just leave it alone. Leave it as a fraction like this. In later courses, you'll break it down more, but right now I just want us to understand the basics of how to get to this point without reducing it further. So now that we've seen how to work through those, let's try one more just to make sure. Okay, we'll do one more just to make sure we know how these work, and then we'll look at applications. So let's do one more. And this is where you're most likely going to be using literal equations. It's something like this. When we go on to the next chapter, we're going to be talking about graphing. And when we graph things, we usually have to solve it for y. So this is another one, and I just want you to solve it for y. And there's really not much to this one. And again, this is a good review. Sometimes these are going to be solved for y. This is the most common application of these literal equations. Is in the next chapter when we solve things for y. So if I want to solve it for y, there's really not much I need to do. I want to get that y by itself. So can someone tell me what I need to do? I want to get that y by itself. Yep, move that 3x over with subtraction. And that is then going to leave me with y equals a minus 3x plus 4. A lot of times students also try to go further. How do I know that I am done? I know that I am done because what variable am I solving for? Y. Okay? Is y by itself on the left-hand side? Yes. Therefore, I know I'm done. Just like the last one. Look at this one up here. We were solving for the variable c. What does that mean? That means the c is by itself on the left-hand side. Is c by itself on the left-hand side on this one? Yes, so we know we solved it and finished it. Same thing with this one up here. We solved this for h. How do we know to stop? If it was solved for h, that means h is by itself on the left-hand side. So that tells me I can stop. And same thing with the very first one that we did. Look at it. We know that this one is done because we solve for the variable b. So b is by itself. What
we just did,
sure.
You have to put negative 3x plus 4 because you put like 4 minus 3x.
Okay. Normally we would write the x first on these, but it would also be acceptable to write it just like this. Okay, those are the same. Normally, though, we would put the x first. When we graph equations, the x always goes first before the number. But if you wrote it this way, that's fine as well. Order does not matter because it's commutative. Just make sure that that negative sign still goes with the 3. So that's the important part. If you switch the order around, make sure that that negative goes with the 3x there. now I'm going to give you some equations. I'm going to give you some numbers, and you're going to have to find the missing part. So I'm going to give you an equation. I'm going to give you different pieces. You're going to have to find the missing piece. Okay, so you're going to be given this formula. And I'm going to give you two of the pieces, and you're going to find the third piece. So let's just do a pretty easy one here. Let's say I give you this formula, and I give you B is how about 10, and H is 5. So in this case, the one that we're missing is A. So I want you to find A. So I want you to find A, the value of A. Now I gave you the numbers to plug in. So this one was actually pretty easy. We plug in our numbers here. And we were able to solve it for the value of A. Because when we plug in numbers, we get a number out. So we were able to plug in the values for B and H. We plug them in. And we can go ahead and solve this out. So what's half of 10? 5. And 5 times another 5 is a 25. So what's our value of A in this case? 25. Let's try another one. This one's going to be a little bit more difficult.
Okay.
Sure.
Can you show me that again?
Okay. So on this one, I gave you this formula. And I want you to find A. Find the number for A. So you're going to be given these values. So I said, I'm going to give you that B is going to be 10 and H is going to be 5. So then we plug them in. So the 10 goes in for the B and the 5 goes in for the H. And then we just multiply across. Well, what's half of 10? Okay, half of 10 is going to be 5, right? And 5 times that 5 left at the end makes it then 25. Does that make sense?
Yeah.
Yep, these are a little bit easier than some of the others. So on some of them, you're not going to have any numbers to plug in, but on others, they're going to give you the values, and you find the missing component. So let's try another one here. And let's say we're given a D of distance of, let's say, 40. And R of 8. Okay, so this is what you're going to be given. You're going to be given this formula. And so that's what you're going to be given. Now, I want you to find T. So T is what we don't know. You're given D is 40. R is 80. Sorry, R is 8 then. So we're going to plug our values in. So we know that D is 40. So my 40 is going to go on the left, because that replaces the D. And then our R is 8. And what piece do we not know? T. So that's going to be 40 equals that 8T there. Now we need to solve it for T. So we plugged our values in. How are we going to find the value of T? We have to divide both sides by what? 8. And that should then give you T is 5, I believe. Because 40 divided by 8 should be that 5. Yep. And that's going to give you then T equals 5. We're now going to be using this concept with the applications. So these applications that we're looking at next, we're going to be using different formulas, and we're going to be plugging values in. So we're going to be using different formulas from the back cover of our textbook and plugging in values to find the missing part. So I'm going to pick these from our textbook to look at. Just so we get a good mixture of different problems here. And let's see. Let's look here at a couple of these. Let me find a couple of them for us to look at here. And these are just going to be using the formulas from the back cover of our textbook. Okay, and let's look now at how about, and this is on page 154. How about we look at 51? We're going to read the question. Now, these are just going to be going to the back cover of the textbook, finding the formula, plugging in the values, and solving. So these are actually quite a bit easier than the ones we did in the previous section. So the area of a triangular road sign is 70 square feet. If the base of the sign measures 14 feet, what is the height of the sign? So let's think about what we have. We have an area. Now I don't put units of measure on until the very end. And this is again is on page 154. Okay. We know we have a triangular plot of land, or triangular sign here, and that area is 70 square feet. So the area is 70. We know that the base measures 14 feet. So the base is going to be 14. We want to find the height. And this is a triangle. So it's going to be a triangle. Now we go to the back cover of our textbook. And in the back cover of our textbook, we've got different formulas, and we're going to go now to the triangle. Okay, that's a trapezoid, parallelogram. Triangle one is right here. So we've got a triangle. Now, we're not working with the perimeter because it says we're working with what? Area. Okay, so back over our textbook, we looked up the triangle one because that's a triangle, and we want our area because that's one of the key components is area, not perimeter. So we know area is equal to 1/2 base times the height. So that's our formula. Now we can plug in our values. So what are our values? Well, we know that area, okay, this is A. Capital A represents the area. So that is your 70. And we've got 1/2. The base, that's your B. And that's 14. And we've got the H left there. Because we want to find that H. So we went to our back cover of our textbook. We found the correct formula. We plugged in our values. Okay, let's go ahead and solve this one out. Now, we don't have to clear out the fractions because when I look here, we're working with numbers. What's 1/2 times 14? What's half of 14? 7. So that's going to give you then 70 equals 7H. Right? Because half of 14 is 7. We need to finish it out. So we're going to divide by 7. And that gives you now H is going to be 10. We need to make sure that we label it. So when we look at question 51, it's got feet in it. It says this triangular sign has 70 square feet for its area. Its base measures 14 feet. We want to know the height of the sign. Well, everything's in feet. Okay, height is something we would measure with a ruler or a yardstick. We'd measure that, and that's going to be in terms of what? Feet, right? Because you measure it, not feet squared. Feet squared is an area. This is something you can measure. So we got our height of that sign to then be what? 10. And we'll put the units of measure on there, feet. Okay, let's look at another one. How about question 54? So question 54. The Rogers Centre in Toronto, Canada, is the first stadium with a hard-shell retractable roof. The steel dome is 630 feet in diameter. To the nearest foot, what is the circumference of this dome? So let's see what we've got. We've got 630 feet for the diameter. So our diameter is 630. Yep, 630. So that's our diameter. And we want to find the circumference. So that's what we're going to be trying to find, is we want to find the circumference. So we're given the diameter. We want to find the circumference. That means, again, we go to the back cover of our textbook. We go down to the bottom, and we find the circle. Now, there are two formulas for the circumference of a circle. One that has an R, one that has a D. We want the one that has the D because D goes with the diameter. So our formula is going to be pi equals pi D. That's our formula. So C equals pi D. D is the diameter, and that's your 630. Pi, we're going to use the pi key on our calculator. So for pi, we're just going to use the pi key in our calculator. So let's go ahead and plug our values in. We don't know what C is. That's our unknown. We're going to use our pi key in our calculator, which we'll do that in a moment. And your diameter is 630. So using the pi key in our calculator, let's go ahead and work this out. I'll move it up so you can see what we've got here. Okay, so here's our calculator. We have that 630. We're going to multiply it by pi. So we're going to multiply that by pi there. A little bit brighter so it's easier to see. That must be too much. There we go. So we can see that. That's 630 times pi. And how far does it say to round? If we read the problem, it says we want it to the nearest foot. So we want it to the nearest foot. So to the nearest foot, it's going to be 1979. And our units of measure there is going to be feet, because we want it to the nearest foot. It tells you how far to go. And so in this case, it tells you to go to the nearest foot. So we round it to the nearest foot, which was at 1979. One more of these, and then we'll talk about angles. Let's look at let's look at question 59. So same thing here. Now this one's talking about the post office and how they determine how much your box is going to cost to mail. So the U.S. Postal Service requires that any box sent by priority mail has the length plus the girth, totaling no more than 108. The maximum volume that meets this condition is contained in a box with a square end of 18 inches on each side. And what is the length of the box? So we need to make sure we understand what to do on this one. This one's using formulas. Okay, and we're going to have to set it up and find the different pieces. So what do we know? We know it can be no more than 108, and that talks about the girth. And it says the maximum volume that meets this condition is a box with a square end 18 inches on each side. Okay, so they give you a lot of extra information that we really don't need. What they give you is we know that this box is 18 inches around. So here's our box. Okay, they gave you a lot of extra information that you really don't need. So this is 18 and 18. And this is the length, and we don't know what it is. So that's what we have to find. Now, they do give you a little bit of information. We don't need to worry about the girth because they tell you what it is. It's just the distance around. But that's not important because it says the maximum length of this box, okay? And it says U.S. Post Office Service requires that any box sent by priority mail have a length plus the girth no more than 108. It didn't say anything about the volume here. Okay, no more than 108. So we know that our box is 18 by 18 and the length is unknown. Now it says that 108, what is that? 108 is going to be the length plus the girth. Okay, because that's how they do it. Say the length plus the girth is going to be 108. And the girth is the distance around. Okay, so if I look at the distance around, they even give you a picture to kind of see. If I look at the distance around, that's going to be this end here. So the distance around, what's that going to be? Okay, if I add up all the sides on this end here, if I think about what that'd be, the distance around, they're all 18, and how many sides do I have here? On this piece here, I've got 4 of them. So my girth would then be 4 times the 18. Okay, so that's your distance around, and you've got those 4 sides. So 4 times that 18 would then be what? 4 times that 18 would be the 72. Now we know the length plus your 72 equals that 108. And we could use L for the length if we wanted. Wouldn't really matter. We found out that girth. Girth is the distance around. Now we can solve it. What do we need to do? Move the 72 over. And you could use an L for the length if you wanted. You can just keep it as length. Doesn't matter. Move that 72 over. And what's our length? Length is going to be that 108 minus 72. And that is 36. And what is the 18 measured in? We read the question. The 18 is in inches. 108 is in inches. So our length is also going to be in inches because everything is in inches in that problem. And that one was just finding the formula for the girth, which is that distance around, plugging it back in, and then finding the correct length. We'll do a couple of angle questions, and then that's going to finish up this section. So we're going to do some angle problems. And when we look at these angles, There's three things that can happen for angles. For angles, if you're given a right angle like this, so let's say it looks like this. This one is going to sum to 90 degrees. So that sums to 90. So if your figure looks like that, the box down below, it sums to 90. If it looks like this, okay, this one sums to 180. And if they form an X, like this, okay, if it forms an X, the top equals the bottom, and the left equals the right. These are called vertical angles. So this is called a vertical angle. So those are the three things that we may encounter. They can equal 90 degrees. They can add up to be 180 degrees. Or the left can equal the right, and the top equals the bottom. Students generally don't have trouble with these, so we'll just do a couple of these. We'll take a short break, and then we'll come back, and hopefully we can get through 2-7 today. That's my goal, is to try to get us through 2-7. So all we have is a couple of these to look at. So we'll do one of each, so we'll do 3 of these, and then we'll take a short break. So let's look on page 155. We're going to look here at question 64. And I'm just going to draw it up on the screen here. You've got it in your textbook as well. And this is going to be question 64. I'll go ahead and draw it up on the screen. This one is 3x plus 9. Now, when we solve these out, we are not just going to find x. We're going to take that x and we're going to plug it back in. And we're going to get the 2 angles. So we need to make sure we get the 2 angles at the end. Just getting x is not going to be all that we need. We need to do a little bit more than that. Now, when I look at this one, what does it look like? Here's our choices. It doesn't form an X, but it does look like this one here, doesn't it? And this one up here, what did it do? It summed to 180. So this is going to sum now to 180. So this sums, whenever it makes a straight line, a flat line, this is going to sum to 180. So if it makes a flat line like that, it sums to 180. So what do we know? What do we have? Well, we're going to add these together. So we've got 20x plus 10 plus 3x plus 9. And what does that equal? 180. We're going to go ahead and solve it out now. So combine all your like terms together. And that makes it 23x plus 19 equals 180. Move that 19 over with subtraction. 23x now equals minus 19. That should come out to be 161. We'll divide by our 23. And that should come out then to be 7. Now, that is not going to be our answer. That is not the final answer. Here's what your final answer is going to be. your final answer, going back to the original, is 20x plus 10 over here. Now, we know that x is going to be what? 7. So we're going to plug that in. Okay, so we take our 7 that we found and we plugged it in. And then we work that out. 20 times 7, that's 140. Plus another 10 more makes it 150. So there's one of your angles. So that's part of your answer. So you've got to take it and plug it back in. What about the other one? The other one is 3x plus 9. We plug it in. We plug that 7 in. So that's going to be 3 times 7 plus 9. And that comes out to, I believe, 30 degrees. So these are the actual answers here. Not x, these are the answers. So you set up your equation, you solve it, you take that x and you plug it back in. You have to plug it back in to get the angles. 2 more of these. We'll do one that sums to 90, and then we'll do one where they're equal. So we'll do 68. Question 68. This is what we've got. Here's our angle here. And we've got 5x plus 5. And we've got 3x plus 5 as well. And we know that this one is going to sum to 90 degrees, right? That makes that right angle. It has the box down here. So that's going to sum to 90 degrees. So that gives us then 5x plus 5 plus 3x plus 5 equals 90. And these are good test questions. Because on your exam, I like to give you 1 or 2 of these. They're pretty simple, pretty straightforward. So you'll probably see something very, very similar to this on your exam. Let's go ahead and finish this out. We want to combine like terms. So the 5x and the 3x can go together to make it 8x. 5 and 5 here make it 10. And that equals your 90. We'll move that x over. So now we've got 8x equals 80. We'll divide by our 8. And so now we have x equals 10. Is everyone okay with that so far? Everyone see what we did? So we just added them together, and we got x equals 10. But is that going to be our final finished answer? No. Now I like to redraw it again. And we'll leave some extra space here. That way we know we've got plenty of room to write. And we've got 5x plus 5. We're going to have to plug in that 10. So that gives you now 5 times the 10 plus 5. And that's 50 plus 5, which is then 55 degrees. So there's one component of it, 1/2 of it. And what's the other one? Well, the other one is 3x plus 5. So we plug that 10 in. So that's 30 times 10 plus 5. And that gives you 35 degrees. Those are going to be the answers. Very important that you don't just stop at x. You've got to find the actual answers. One more. We'll take a short break, come back, and do the next section. So let's do one more of these. Question 72. we've got 11x minus 37. And down below, we've got 7x plus 27. Now, what do we know? Okay, these form an x, don't they? So the top equals the bottom. So these are called vertical angles. So these are going to form an x. And that means the top equals the bottom angle. Top angle is 11x minus 37. The bottom one is 7x plus 27. So those are now going to equal y because it forms an x. So anytime it forms an x, the top equals the bottom, left equals the right. So they gave us the top and the bottom angles here. So now we know these are going to equal. Now we can solve it. Move that 7 over with subtraction, just like you always would. And now we've got 11x minus 7x. That makes it 4x minus 37 equals that 27. Oh, sure.
This is like the T will be in and out. We're going to check it each time.
Okay. Thank you, Laura. So we're going to go ahead and add that 37 to both sides. And that gives us then 4x now equals, when we add these together, 27 and 37. That gives us then our 64. We'll divide by our 4. And now we've got not our answer, we've got part of it. We've got that 64. We're going to divide it by 4. And that then gives us x equals 16. That is not our answer, though. Okay, to get the answer, we have to find both sides of this angle. Or sorry, both sides of this x here. So I'm just going to redraw it, and we're going to plug that 16 in. So we've got 11x minus 37. So that's 11 times 16 minus that 37. And 11 times 16 is 176 minus your 37. That makes it 139 degrees for that piece. So that's one of them. Now the other one should be the same, because these should be the same. So let's plug it in down below. Down below we have a 7x plus 27. We're going to plug in that 16. And then we combine them together. We've got 7 times that 16 plus that 27. That comes out to also be 139 degrees. And those are going to be my answers. So those are my answers there. Not that x equals 16. That is not your answer. We need to make sure that we go back and get those two pieces there. So let's now go ahead and take a short break, and we'll meet back at 10:25. So let's meet back here at 10:25, and then we'll start the next section.